How forensic scientists examine textile fibers. In forensics, various instrumental fabric and fiber analysis methods allow the identification of perpetrators and victims, making assumptions about the crimes committed. This essay discussed a case scenario in which a suspected sexual assault victim was apprehended by law enforcement. The victim's green sweater, made from a blend of cotton and polyester, and the suspect's blue sweater, sewn from wool and acrylic fibers, were submitted to the crime lab for fabric analysis. The primary need is to discuss the major types of textile fibers used in the industrial apparel industry. A fiber is a structural unit of fabric that is a tiny piece that retains all the properties of the whole fabric and thus is available for analysis. Depending on the source of origin, all fibers can be formally divided into two classes, natural and synthetic. In the above scenario, cotton and wool are examples of plant and animal natural fibers, respectively, that is, they are such fabrics that are found in nature. Natural fabrics include hemp, spinning silk, linen, leather, and down as the most common natural fibers. In contrast, polyester and acrylic fibers are synthetic textiles produced artificially using chemical-mechanical techniques. In addition to these two, synthetic fibers include, but are not limited to, viscose, polyamides, nylon, mineral fibers, and lycra. Notably, synthetic fabrics turn out to be cheaper and often have more advantageous characteristics for manufacturing, which are also relatively easy to manipulate. Therefore, manufacturers prefer to use fully or at least partially synthetic fabrics as an alternative to natural fabrics. In turn, synthetic fabrics can be produced on a matrix of natural fibers, as with bamboo. For this purpose, bamboo fibers are artificially processed to isolate cellulose, after which the material is given the necessary organoleptic characteristics. A microscope is an indispensable tool for researchers to study the structure and composition of fibers in the forensic laboratory. Engineering science presents a vast selection of microscopes, depending on the needs of observation, aperture, and the corresponding complexity of the device. The most classic of these is the optical microscope, which uses daylight or artificial light to illuminate the slide. The technician selects the lens of the desired resolution and observes the fibers through an eyepiece or digital application. A more advanced type of optical microscope is the stereo microscope, which uses reflected rather than passed light. The use of a comparison microscope allows observation of two objects at once, for which the optical paths of the lenses are bridged. The identification of the sample with the reference is simplified. Using an electromagnetic field in microscopy creates atomic force microscopy, which maps the surface of a material through laser probing. If a flux of electrons, rather than light or even laser flux, is used for irradiation, this forms the operating principle of the scanning electron microscope, which allows information about the type of fiber surface to be obtained with high accuracy. The transmission electron microscope, unlike scanning, uses electrons that have passed through the object rather than reflected electrons, which makes it possible to obtain data on the observation of objects of cellular and submolecular size. Thus, the main differences between the microscopes used include the type of excitation used, the structure of the device, the optical pathway, and the type of information collected, reflected or passed, and the maximum resolution for the object. When analyzing the collected fibers in the lab, specialists can use a comparison technique. First, this involves comparing the composition of the suspect's and the victim's fibers, and if the suspect's clothing fibers are found on the victim, this becomes evidence. Second, this comparison can be based not only on the structural composition of the fibers but also on their color using microspectrophotometry, which can also be a powerful piece of evidence. Third, different fluorescent media can be used for microscopic observation if the fibers prove to be poorly distinguishable. Fourth, if the fibers are externally indistinguishable, FTIR, Fourier transform infrared spectroscopy, can be used to analyze them as an alternative to microscopy for qualitative material identification. Fifth, not only the quality but also the quantity of fibers detected can be a means to find evidence. A single fiber found on a victim is not yet evidence of a crime, but multiple such fibers significantly increase the likelihood of a link between them. Finally, the quality of the fiber and its organoleptic properties, including its appearance, may be additional evidence of the age of the crime. Therefore, collecting and storing such evidence is an essential element of an investigation. The reliable collection includes the use of adhesive tape, forceps, or sterile gloves to prevent damage to the fiber. Transparent plastic packages should be used to store the clean sample, which allows for quick identification of the evidence and prevents exposure to the outside environment.